I'm delighted to introduce Phil Smith today, who is the Teacher Scientist Network Coordinator based at the John Ennis Centre. So Phil and I go back a number of years, but Phil originally set up the Kit Club scheme in Norwich, and that Kit Club programme, for those of you who've been teaching for a number of years, might have remembered that it was housed at the Science Learning Centre in Durham. Unfortunately, the kit was left at the centre and wasn't used for the last 8 years. So with a stroke of magic and a little bit of Christmas spirit, we managed to get our hands on the kits, and the kits will be available to schools, both primary schools and secondary schools in the North East, and it is a fully funded programme, so there is no charge to the school. If you lose anything in the kit or damage anything, we would ask that you do replace it, and we do have some terms and conditions of use that you will have to sign. So we ask that you read the terms and conditions and you contact the STEM Hub, and we are going to be setting up an email address which will be resources@rtcnorth.co.uk. I will follow this meeting up with a series of further information about how to access the Kit Club. But just in a nutshell, we have some fantastic kits. I'm going to run through them now, and then Phil is going to run through them in a little bit more detail. Not all of them, or else we'll be here till tomorrow morning. But I'll run through the ones that we have at the minute that are housed in Sunderland and are available to be used after Easter. Now, obviously with COVID, the use of equipment and transportation of equipment is difficult, but hopefully by the time Easter comes and goes, we'll have a better idea as to what we can and can't do. But fingers crossed, with a fair wind behind us, we should be able to hire that kit out to you with very few problems. The kits we have available are Advanced Magnification, which includes a set of 10 microscopes with different lenses. We've got cars and ramps. We've got a climate change and biodiversity kit. We've got an electricity kit, a friction kit, general forces kit. We have a genetics kit. We have a healthy eating kit, which Trish knows all about because she had to count about 1,000 pieces of plastic fruit, but that's healthy eating. We have the heart, which Phil's going to run through today with us. We've got magnification, which Phil's also going to do a little bit of a session on as well. Microorganisms, very topical, and Phil's going to do a practical, which is very topical, about hand washing as part of our microorganisms kit. We've also got the skeleton, so we have a full-size skeleton that you can loan out for your school. We have a smart materials kit, which is probably more for the secondary school students. We have a sound kit, which Phil is going to run through this afternoon with us. We did a little bit of a test and all seemed to be working this afternoon. We have the sensors, so a kit with all sorts of different pieces of equipment to do with the sensors. We have 2 torsos, so it's always interesting when you're transporting stuff. So we have 2 torsos with interchangeable body parts. Phil's going to demonstrate that this afternoon as well. We have a water cycle kit, and we have some water investigations as well. So those kits will be available to you as a school to loan out from us free of charge. We will let you have them for 6 weeks, so half a term at a time. And we do ask that you come to Sunderland to collect them, and we do ask that you drop them off as well in Sunderland. I actually live north of the river, so if anyone wanted to meet me at Silverlink at a time that's convenient for us both, I'm happy to do that to save you having to traipse through the tunnel backwards and forwards. So we can work with you on it, but the basic information is we'd ask you to come and collect it from Sunderland. We're just on the 1231. We're 5 minutes down the 1231. If you could come and collect it and then drop it back off. So in terms of Kit Club, it's been running incredibly successfully with Phil at the John Ennis Centre. It's been running for over 20 years, so we are both that old. It's amazing how long ago that is. And it's available to schools in the North and Suffolk area. And what happened was Phil actually applied to the Department for Education at the time for funding for 3 satellite venues, and one of those venues was the Science Learning Centre in Durham. And I know that that kit was very, very valuable to a lot of schools who used it time and time again. And we had big kit club conferences. So harking back to the good old days, but no, fantastic resource. And I'm so pleased that by a stroke of luck, we managed to get our hands on it. So this afternoon, bear with us because Phil's trying to do something that I don't think either of us have done since COVID hit. We're trying to do a remote session with hands-on activities and demonstrations. So bear with us. Phil's going to go through the friction kit. He's going to go through microorganisms. He's going to go through some microscopes, the magnification kit. He's going to assemble a torso in less than a minute. So he did this on radio, and he's going to have another go at it this afternoon. He's going to do a little bit on general forces and sound and the heart. And what we sort of discussed was after each kit or after each demonstration, Phil will stop, and then any questions, if you can put those in the chat, and then I will ask Phil those questions. So I'll be monitoring the chat facility, and if anyone's got any comments or any questions, then please do put those in the chat, and I will ask Phil at the end. And apart from that, I think that's everything from me, Phil. Are you happy with that? And he is a sort of well, he's half a Geordie because he did his degree in Newcastle, so we kind of adopted him. But we won't talk football, will we, Phil?
We better not talk football.
We've got a mixture of STEM ambassadors and teachers with us this afternoon. So brilliant for teachers to borrow the kits, absolutely fantastic. STEM ambassadors, we would love you to come and grab these kits and go into the schools and deliver the activities. That would be absolutely amazing because obviously we do run the STEM ambassador program. So teachers borrowing them, fantastic. But STEM ambassadors, I'm sure the teachers would love for you to go into the schools using these kits to do some activities hands-on with the kids after Easter. So over to you, Phil. I am going to keep my mic on because if we do have any issues of seeing things, I'm just going to say move it a little bit over to the right, Phil, or move it down. So bear with us, but over to you.
Brilliant, thank you. Thanks, Claire. Hopefully everyone can hear me. I keep getting the odd little warning about my internet quality. So yeah, fingers crossed that we can get through the next hour or so. Yeah, welcome to Norwich, which is where I'm based now. I moved actually from Newcastle down here to be a plant science researcher at the John Innes Centre, which is a world-leading plant and microbial research institute, which is where I'm speaking to you from now. And despite that, we still have the occasional dropout in our internet and our Wi-Fi. So yeah, we're going to battle on with that. I'm going to start with our torso, or your torso, because what is so nice, everything that I'm going to demonstrate here is essentially a replica of what you have access to up in the northeast. Me with the kit down here, able to demonstrate it, and you've got access to the kit yourselves once Claire releases it to you, possibly post-COVID. Possibly before then. I have to admit, our kit club has still seen activity during the COVID times. The issue is in their bubbles, and then you allow the 72 hours, but if you want the kit to move into another bubble, you have that 72-hour period in which you can effectively sanitize the kit. You don't have to wash every item down. The virus should be killed off after that 72 hours. So that should make it possible for you to loan it out and to use it effectively in your classrooms. And the same will apply when the kit comes back into the centre. As it does with us, when our kits come back from schools, we leave them usually over a weekend, and then we start checking them before they go out to another school. So not always possible to do a really quick turnaround with the kits, but that will come as everyone gets a bit more comfortable with a sort of post-COVID era. Okay, so I'm going to kick off with the torso. I'm going to move the chat, Claire, because it's covering me up. There we go. So this is the torso. Hopefully in shot. You'll notice it's got a sports top on it. And that's actually quite significant. I just mentioned this. I think she's about to go into town and start buying football tops, because if you have any kids who have any SEN issues in your class, it should arrive with you, and we suggest talking with the pupils about the fact they are about to see a model of the internal organs of the human body. Okay, so this is it. This is a torso. I have to admit, it's been a while since I've seen your kits. I was actually at the launch of the Kit Club, or the launch of Teacher Scientist Network, if anyone remembers that. And I can't remember if you've got a torso with a head or a torso like this one with no head. It matters not, it's just one extra part for you to lose. So what I'm going to do here is I'm taking off, these are the lungs, and you might be all sat there with little notepads thinking, oh, we've got to scribble frantically at this point and make notes about what's in all the kits and how to use it. Well, one thing Claire didn't say in her introduction was the fact that all the kits are supplied with really useful teacher's notes. Here's one I prepared earlier. So this is our General Forces kit. We'll come to that shortly. Very simple, very accessible document that we reckon only takes 10 to 15 minutes of your time to read before the kit. Now, it might have ideas for lessons in it. It might just have tips on how to use certain pieces of equipment in the kit, but it's going to help guide you when you actually have the kit in your classroom. So by all means, take notes, but you don't have to write down everything I'm about to say in the next hour. So we're going to take the torso apart because it enables us to introduce our learners, our students, to the different. So down on the table in front of me, I have placed 2 lungs, a heart, a kidney. Guesses in the chat as to what that is. We'll come back to that. Just get you guys using the chat a little bit. Got this item here, which is the stomach. And here I'm showing you the interchangeable genitals. Hopefully we're not about to be removed from broadcasting at this point. So your torso can be male or it can be female. And then you also have the intestine here, the large and small intestine all together. So if you want to start a little timer, Claire, just maybe in the corner, it doesn't have to be live on screen. I'm going to try and put this guy back together again. 7. We've got 8 items. Did anyone make a suggestion as to what this might be?
We have the liver.
It is the liver. And remember scale, and that's what always surprises me when I look at this model, just how big this thing is. Really, it's significantly bigger than your stomach, certainly when the stomach isn't swollen. Anyway, okay, so we're going to try and get this all back together, and I'm going to start now. Okay, so interchangeable genitals, they're obviously going to go down here. Might not do it in the minute if I'm doing a bit of pointing. What you maybe can't see is that the different blood vessels are color-coded as well, so you can make sure they're matched up. And as I say, you can be male or you can be female in this particular model. So the interchangeable genitals are in. We then want the intestine, so you get much of the body cavity is filled with our intestine. You'll see some internal organs there. The stomach sort of sits on top of the intestine. The liver is going in there very nicely. The heart actually comes apart. You can see the chambers of the heart. Get them back together. And it's supported on a little hook. So the hook goes over there. And we've got the heart now sitting in the chest cavity. Oh, we've forgotten the kidney. So we've got the little kidney down here. That's probably what you will do when you return the kit to the centre. You'll forget that the kidney should be hooked on. We don't want to lose that. We've managed not to lose our kidneys, so hopefully you'll be all right. Okay, that's back in, and then obviously you've got your pair of lungs. They also hook over on little hooks and eyes, and there you go.
140.
Their body part inside their frame, their skeleton. You could link it perhaps with loaning the skeleton. I didn't bring our skeleton over, but yeah, they're full size, the skeletons. The best way to transport them, by the way, everybody, is the skeleton travels on the front passenger seats. Bear in mind this kit is going to go back and forth. I'm not making a joke when I say that. The kits are going to go back and forth from schools to the centre, from the centre out to schools. You're going to have to look after some of these items so that they survive this process. Our last skeleton survived well over 10 years doing this, but he always travelled on the front seat of a car. So you seat him and strap him in with a seat belt. It's up to you if you want to put a blanket over him. My centre happens to be based right next to the main county hospital. And so there were people who combined their visits to the hospital with collecting kits. Why wouldn't you? And so when they did that, they brought blankets and covered the skeleton so that it wasn't visible to people who were also parked in the hospital car park. So just bear in mind those little things when you're transporting these things around the northeast. So not just for decency, but as I say, if you've got any children who are going to be a little bit shocked by human body parts, they may be quite used to the sort of the person in shorts with the skin over what is under our framework that can be quite shocking. So that's the torso. As well as the torso, you get a small box of supporting materials. I'm hoping at this point Claire's going to continue to nod, or else I'm wrong. Yeah. And those supporting materials include flip charts that can help you actually familiarise the children with where these different things are in the body, how you spell the words. You could do body part bingo, just like you could do bone bingo with the skeleton, so that when you're pointing to a particular body part or holding it up, they're matching. You can play those sorts of games using the material that you're provided with up there in the northeast. Okay, I'm going to pause at this point. That's one kit down. Any questions about the torso?
Yeah, there's nothing in the chat, but if anyone wants to put anything in the chat about the torso, I think it was a very good point about the SEN students, Phil. You know, we caught up this afternoon. I hadn't realised that would be such an issue, so it's a good point to make sure that the torso is covered if you do have any children that might be slightly distressed by that. No questions so far. Oh, sorry, Steve's asked, is there a head model? We do have a head. So this is the magnification one.
This is magnification. So I'm just going to show you a simple, very basic junior microscope that I think we supply, or you supply 6 in the box.
Oh, 10.
10, wow. So those boxes are going to be very heavy. Again, a general point about some of the kit boxes, they will require, I guess the guys at the centre can help you load up at your end, but you might well require help back in school unloading your car when you get there.
Yeah, they are heavy.
So, because with every single microscope, we're also supplying a table lamp. This might not actually be required if your classroom's quite bright. If your classroom's quite bright, or you can arrange the microscope somewhere near an outside window, then as I say, you might not need the lamp at all. I'm going to switch it on. Just works in the normal way, just a little hand switch on it. You'll see there's a warning that, well, you might not be able to see the notice, but
These, because they're the old school lights that actually give you some brightness, they've got the old school bulbs in, not the renewable bulbs. But this means that these things get really, really hot. So there's a slight health and safety thing to bear in mind when you're using these things, okay? So we also provide a sort of set of already made slides. So there are 3, and these are beautiful. These are absolutely beautiful. We had a volunteer work for us for years and years, and she made all these, mounted them, she dried them, and they're all catalogued. And so you get, already you've got 60 slides here. So little slides, they're labelled on the back as to what they are, so you don't have to worry that you don't know or don't recognise them. They're made out of laminated card, so you haven't got a glass hazard, which is really nice, I think, to hold it in place. The microscopes come with their own little guidance notes that will be laminated. There's very little the children can do to actually damage these things. They're pretty robust. If children wear glasses, we suggest that they remove them when using a microscope. These, you'll see, have only got the single scope. So what you want to do is get your dominant eye, which is the eye that you can't really blink with. So I can blink with that eye, so I'm going to look down this eye and cover my dominant eye. And that just enables you to keep your eye muscles relaxed when you're actually looking down a microscope. Because one of the biggest problems people have is they get all quite tense, and then they start getting headaches just from the tension of just forcing their eyes to look down this single scope. You've got the 2 wheels here which adjust the focus on the microscope, and we're going to take a look down here. There's a guiding light, and I just need to get this in focus. And so you're just rotating the wheel a little bit forwards, a little bit backwards, until you can get it exactly in focus. And the resolution of these things is genuinely remarkable. So I'm looking here at a buttercup that, as I say, was laminated probably about 10 years ago, and I can still see pieces of pollen on this slide. So you've got a ×10 objective lens here. You've got a ×2 on your eyepiece, so you're magnifying it about 20 times in total. And these things are really just going to open up the natural world to kids and really just bring that wow factor into your classroom. As I say, this is something as simple as looking at a daisy, but I said we provide other sets of slides. There's one on materials, and there's one on soil, salt, things like that. The materials, if you've ever looked at pieces of Velcro, or if you haven't looked at pieces of Velcro under the microscope, you're missing a trick. It's an amazing thing. You can actually see the structure of the hook and eye within the Velcro to explain how the thing works. It looks nothing when you see it on a straightforward slide like that. Pop it under the microscope and you start to see the arrangement of the fabrics. And now I've got the microscope roughly in focus for my eyes. I'm probably not going to have to change it very much as I move from slide to slide. So if you can give one child a little bit of time on the microscope before moving to the next one, that's going to be more efficient for you. Otherwise, because everyone's eyes are different, there's going to be quite a lot of adjustment going on when the children are using these microscopes for the first time. When they're looking down them, they might start saying, oh, what's that pointy thing, that black thing? The chances are they're looking at their own eyelash. That's one of the most common mistakes young people make when they're looking down microscopes. The other thing to bear in mind, inside the lens, there is a pointer. So if you as a teacher want them to focus on one particular item If it's the wing of an insect, for example, then you might want to have that arranged beforehand, either by yourself or by your TA, so that the pointer is actually on the object you want to draw attention to for your children. Or you might just want them to explore and get excited by what they see. So yeah, you try and keep both eyes open because it keeps your eye muscles more relaxed, as I said at the start. It's not dreadful if they're squinting, but as I say, best avoided. And just let them explore, see what they can see, start asking questions about what they're looking at. And if you can encourage that child creativity, the questioning skills, trying to understand why something might be designed in a particular way, then you're really going to engage the children in the activity. So, as I say, really simple to use microscopes. The one thing you don't need them to do is there is a screw at the back here on the main arm of the microscope. It loosens quite readily, and kids think, oh, I've got to get down really close to this. And what they'll do, they'll try and turn it around, or they'll try and drop it down really low. You actually just want to be about a thumb's distance from the top of that stand. That's probably the optimum distance for most people's eyes. So, and you obviously want it at 90 degrees. So there we go, should be back to normal. So that's the junior microscopes, which are absolutely ideal for primary school use. As I say, they're pretty robust. So every now and again, the focusing will become erratic, and then Claire and colleagues will just pull them out of the kit. If you have one that goes like that, just remember to point it out to them when you return the kit, maybe making a little mark on it or putting a little sticker on the item that is defective, because that's standard wear and tear, and that is going to happen. I'm sure they're not going to give you a hard time if it happens under your watch. So yeah, you get 10 simple microscopes. I'll talk a little bit about the advanced microscope while we're on the subject of microscopy. These are probably more suitable for secondary schools. They have a ×4, a ×10, and a ×40 objective lens, which obviously allows them to look at onion cells, for example, and you want to see the cell walls and you want to see the nucleus. They work perfectly for that and give really, really good resolution. But it might be appropriate, even in a secondary school, if they haven't had much hands-on experience with the microscopes, to start off with a junior set, get used to the focusing aspect, and then move on to the more advanced ones. Okay, another little pause.
I am going to correct myself. We have only got 6 of the junior ones. So you were right, Phil, 6. It's 10 of the advanced magnification. It's 10 of the secondary school kit. Yeah.
Okay, so it's an exact copy of how we do it.
Yeah. So if there's any questions, because I know teachers really struggle, particularly primary schools, to get their hands on microscopes. You know, and as you say, it opens up a whole new world to them. Even if you find a dead ant or something, or a dead bee, and put it under. I mean, it's incredible what you can see with just a very basic microscope.
Yeah, but the optics on these are so good. These simple scopes is really quite amazing. So yeah, and I think the fact that we provide the slides for you is another real. How many people are on the call at the moment, but there's probably over half of you have spent many an evening, many a lunchtime scurrying around trying to find bits that you can put under microscopes for the kids to look at the next day or even that afternoon. So by providing the slides ready-made, or providing little petri dishes with some of the dead insects or flower parts in them that are also in this kit box, we're hopefully making your lives a lot easier as well, in terms of enabling you and the students to start looking at things under microscopes. And again, it's a life skill, really. You know, if they're thinking about science in future careers, we still use microscopes an awful lot. The institute that I'm in here, turn that around. Step a bit back. Am I still in shot, Claire?
Yeah, you're still in shot.
Microscope here that's got the basic lenses. It's got a 10 times, it's got a 40 times, but it's also got a 60 and a 100 times, which you use with oil immersion. So yeah, those of you who've worked in research before you went to teaching, again, it's a nice chance to reconnect and make those links. Real scientific equipment that they're working with, because that can be quite exciting for young people as well. Okay, we're going to go on to a bit of physics now and talk about the general forces kit, which I mentioned in the introduction because it was the first set of teachers' notes I could lay my hands on. And I'm a biologist by training, so I'm going to open the teachers' notes and reference them myself as we go along through this. So every kit gives you a real detailed inventory as to what is in the kit. You can use that as a little tick list so that you know you make sure that one, it's all there, and that two, you return it all to them when you're finished with it. So you can tick this off as you go along. There's links usually to curriculum objectives and gives you hints about which activities might work particularly well. And then we've got 2 or 3 pages on suggestions for using the kit resources. Okay, so I'm going to begin. What am I going to begin with? I'm going to begin with this. Okay, so you might know this as a swimming woggle, which you prop under the children and hope that they float. But you'll notice I'm able to change the shape of this woggle. I can turn it into a total circle. I can even turn it in on itself if I use a bit more effort, or if I use a bit more force. There we go. So we've sort of squashed it into the form of a bit like a snail now, and it'll unfurl. But every time I change the shape of this object, I'm applying a force to it. And this is the basics of learning about an introduction to forces. Is that if you apply a force to an object, one thing that can happen to it is that it can change its shape. So that's what the woggle is for. Feels a bit like Blue Peter, this, from my end. I'm at the back of, and you can see a white table. Okay, into shot came a little yellow tractor. Okay, how did that tractor get from me onto the screen? I applied a force to it. I applied a push force, and it made the object move forward. And that's what. I don't want it to go that fast. So what we have in general forces is a whole load of toys that all work in some way by applying these simple rules of physics about a push-pull force. Because this is, I love this.
I love this as well.
Okay, so these are the woodpeckers on a stand, and give them a little flick. Let's get him below the. There we go. So, question to you guys: how is the woodpecker going from up here to down here? What's happening?
Answers on a postcard.
Answers on a postcard or in the chat, or I'll just tell you.
basically it's gravity that is allowing it to fall from on high. The spring is enabling the woodpecker to bounce forwards and back, and actually pauses very momentarily due to a bit of resistance in there. So you've got a bit of friction that's preventing the smooth movement down. Whereas if you just drop a ball from high, and it's from top to bottom. And again, if you roll it, it rolls because I've applied a push force to that ball. So most of the time you're seeing me applying a force here. If it's in any of these toys, I'm applying that force, but it doesn't have to be the person applying the force. It can be other things. It can be water, for example. So, because the chat window's open, I can't see this, Claire. So hopefully
yeah, I can see it. Yeah.
Can you see that wheel going round, the blue thing? Yeah, okay. So I can flick that wheel to change it. What I can also do, because it's a water wheel, a bit of laboratory equipment, just to demonstrate a point. So just got water. And the water is now making that wheel turn. Not wonderfully because of that.
Yeah, we saw that, Phil.
Yeah, is that okay? We're seeing that?
Yeah. Yeah.
Before I flood the bench totally.
There's quite a few of those in the kit as well.
There are, so you can use water or you can use sand, which might be a little bit easier to make those things move again. So you've got an external force. So in some cases you've got force. In cases it's the object that's impacting against it. Okay, so we've got that. And there's a whole load of things in this box. I think that's the beauty of the kit. We haven't focused too much on this yet. There is so much stuff in every single box. And there's a deliberate reason for that. We want children to be able to be hands-on and not be sat there waiting for the bit of kit to become available. So most of the boxes are designed thinking that children are going to work in pairs or maybe in groups of 3. So here, for example, we've got the beanbag animals. Again, you can change the shape of these things by applying a force to them. But we've got 10 beanbag animals. We haven't just got one. The water wheels, in the one I've got here, we've got 4 water wheels in the box. A great number of different cars and little toys. We've got 2 of these. So one time when I used this kit in the classroom, we created a sort of circus of activities for the pupils. This was when I was working as the equivalent of a STEM ambassador, actually, alongside a teacher, so working in partnership. And we planned how the session would run together. We had joint ownership of it, and we jointly delivered it. So we had about 5 or 6 stations, which were the tables in the classroom, with different bits of kit laid out on each one, and just gave the children 20 minutes to play. Because this was in the days that learning about forces was in Key Stage 1, since been taken out of Key Stage 1, because the Institute for Physics were saying that there were too many misconceptions developed in really young children by teaching physics badly to really young ones. They've now teaching of forces is entirely in Key Stage 2. There isn't the introduction to it in Key Stage 1. So again, there's no reason why the older ones in your primary schools can't be introduced to forces in this way. And there's actually no reason why an A-level group can't explain to me all the different forces that are going on. So I've known sixth form groups take this very basic kit and start to think about the actual describing the forces and measuring the forces, which are more detailed concepts that obviously you don't have to get into when you're doing it with the younger ones in primary school. So you've got objects that you want to make move, you've got objects that you're going to change the shape, you're questioning why things fall. You're also thinking about why do things stop moving. So this water wheel, for example, if I flick that, yes, it spins around, but suddenly, what's happening? What is acting on this water wheel? Well, it's the effect of friction. Things don't continue to move because friction acts upon it, and that friction is acting against the force that you have applied to it to make it move. So you've got air resistance actually stopping the movement of the wheel going round there. You can think about what makes it move. We've also got in the kit really nice things. Get some more bags out. This is all from the same box. You've got the equipment, I think, to make a little diving submarine. So you've got a chemical reaction there between water and baking powder. That produces carbon dioxide. The carbon dioxide lifts the submarine off the bottom of the vessel that it's sat in. Balloon-based racing cars, and the force is coming from the balloon. It's that forcing the air out through a small hole, and that's enough to give us a force to project the car forwards. And we've also got bubbles and blowers as well. So essentially, a push-pull force is going to change its shape, it's going to change something's speed, or it can change the direction in which an object is moving. And there we go, that's a very simple introduction to using forces. And we think the most effective way of teaching that is by providing you with lots and lots of toys so that the children can have fun. They can use objects that they're already familiar with to investigate it in more detail and think about, okay, yes, you're used to seeing the dumper truck and you know that something will fall out of the back of the dumper truck if there was something in there, but what have you done to raise the this part of the dumper truck? Well, you've applied a force to it, and it's actually rotating on a spindle there, so you can bring in a bit of extra language as well. Can we have either a thumbs up or thumbs down on the little raise hand facility if we're doing all right so far? Because it is very weird for certainly me. I am talking to myself in a large cavernous laboratory, and are people happy with what they're getting? Is the sound quality good enough? Are we going into enough detail in the science, and obviously giving you a flavour of what's in the boxes themselves?
We're getting lots of hands up, so that's good. Yeah, lots of hands up, Phil. I think it's just it's the connection, but it's the world that we're in. You're in Norwich, and we're in the northeast, so we get there eventually. We're just bearing with it. Yeah, it is tricky. It's tricky with it cutting out, but I think it's just we're just sort of showcasing what is available, and then obviously once teachers are allowed, they can come to the centre and we can go through the kits again with them physically face to face. This is just a sort of a general overview. Yeah, lots of thanks. Yeah, the explanation how to use them is excellent. So yeah, we're just skimming the surface at the minute today, aren't we?
I know you told me it was a characteristic of yourself earlier, Claire, but you started to sound a bit more roboty in the last minute or two, which is making me a bit nervous. But
that's just me. My
just in
colleague
case
will
you
tell you
decide to
that.
terminate me or something. Okay, we're gonna stay with physics. We've done the introduction to forces, so now we're gonna think the next stage on. Once you've introduced your pupils to the idea of a force and what it is, we started to mention one of the reasons that some of those objects slowed down was due to the buildup of friction. Well, we have a whole box that is dedicated to friction. So be really distinct when you're ordering your boxes. Okay, so this is the friction kit. There are 10 ramps, 10 stands, and 10 friction blocks. So these are straightforward bits of wood, about what's that, 5 or 6 inches long, with a different surface on each side of the piece of wood. So that's bare wood. This one's got a piece of rubber across it. This one's got some felt on it, and this one's got glass paper or sandpaper on it. And what we're interested in the question of friction is which of these creates the most friction, and what is the effect of that friction, and how might we investigate it? So the other pieces of kit that we're going to use, we've got the block, we've got a little beaker here with a tiny little piece of string on it, or quite a long piece of string, and that string has got a loop on the end of it. Okay, that loop simply hooks over the hook and eye that is placed on the end.
Have you got your eyeglasses on?
Hand's not stable enough. There we go. So we've got that hook. Well, I didn't bring a ramp to go from this. We're going to work on the lab bench. So moving you down. Okay. So we've got hopefully, and we're just going to rest the beaker over the side of the bench, so it's just going below me now. Okay, and we also provide a little collection of 2p pieces. So we've got 30 2p's in every bag, and there are 10 bags in the kit. Again, so you're looking at children working in groups of 30. If we start adding the coin, keep your eyes focused on the block. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28.
James Deal, please contact reception as a matter of urgency, please. That's James Deal to contact reception as soon as possible. Thank you.
Okay, just about announcement. We got, I think it was to 28. Okay, so all I've done is change the surface. We're now on the rubber surface. I'm going to get the coins again. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Just about starting to go there. So I won't flog a dead horse, as it were. Obviously, you can test it on every single surface. You can get data, you can get numbers about the amount of coins that you're having to add to the beaker. The more coins you add, the more weight you're applying down here, which is applying more force to the block. So then you get a measure of how much friction there is between the different surfaces and the surface of your inclines as well. You can investigate that. You can look at the effect of the incline, whether it's at that angle or that angle, really steep. But I will give you a boy-girl warning.
at this point, and this is not at all a sexist comment. This is from years of experience. The way children add coins to the, as to how it reacts in terms of when it starts to move. What you're waiting for is the smooth movement, not the first movement, because you get a few boys coming along and going like that and just chucking in the coins. Now, I've only added about 20 coins there, but it moved straight away because they were adding large numbers of them, and so there was a force from them throwing into the beaker, and it's always boys that do it. I don't know what it is. The girls hit coin by coin by coin, which is the way you want it to be done, so that you can get some data. Because of course, once you get data, then you can start talking scientific inquiry, as well as questioning how to design the experiment to investigate friction. You can also be thinking about, okay, how do we analyze this data that we're getting, and what do the numbers actually, and how do we know that when we use the rubber surface, maybe it was just luck that 28 made it move. So we have to replicate our experiment. So they do it multiple times, or you get different groups comparing their results. If they're all working from the same surface, then it should all give you the same result. What if it doesn't? Do you take a class average? So then you can bring in some maths to the investigation. So there's an awful lot that you can do about designing the so-called fair test. I know that term has slightly gone out of fashion, but the gist of it is still the same. You want to be able to replicate these things, and then actually you've got a sound experiment that is really well designed, and you can be confident in the data that you get out. And all the equipment provided, and you might have noticed these earlier in shot, which is how we measure forces, over the end of the block, okay? And then there's a scale on here, which tells you the number of newtons on the block. That spring moves, and it will give us a value on the Newton meter. So you can actually do it, and you can actually get a measure in newtons of what it takes to move that block. So it's about 0.5 newtons is required for me to be pulling that block across the table. Again, that may, once you get into newtons, it might be secondary schools that are borrowing this equipment with the assumption that secondary schools are better equipped than primary. But as secondary schools, you're thinking of borrowing this equipment as well. But it's you who are going to want to use this more technical language and be thinking about what is a force measured in. Well, it's measured in newtons. Now, yeah, if we're on friction, right, we're now going down onto the floor. So, when you've done experiments with friction in the past, some of you may have thought about buoyancy and upthrust, and you may have tried to time how long it takes for an object to fall down through some water or through a viscous liquid. You may have made up wallpaper paste in the past in the sort of largest tube that you can find in school, which is typically probably no more than a 1 litre measuring cylinder. Well, if we do that, I've got an object here. It's quite heavy. It looks like a silver foil ball, but I put some coins in it before. If we drop that in, and we'll try and time how long it takes for it to get to the bottom. 1, 2, 3. That wasn't too bad. We could actually time that. But so many of you, I'm sure, in the past have dropped things from that sort of height, and it's hit the bottom before the timer has ever started to do anything to help you. Enter. Are we seeing my shoe, Claire, and are we seeing my hand?
Yes, yeah.
Yeah. So this is a giant Perspex cylinder. It's probably about 1 meter off the ground, the water level here. And then we can start dropping objects and timing how long they take to fall, because they take a reasonable amount of time that you can even count it out loud. We'll try doing this. So the object is just touching the surface of the water now. 1 elephant, 2 elephant, 3 elephant. Okay, 3 and a bit elephants. So 3 and a bit seconds for that object to fall to the ground. It's floating, it's not sinking. Another one. 1 elephant, 2 elephants, 3 elephants, nearly 4 elephants with 2 pp's to fall down. You've probably done this by creating different shaped objects out of plasticine, out of blue tack, timing how long they take. By doing it with something so large as this, it means you can actually, as I say, get some more data to interpret. And the children aren't going to get frustrated by the experiment and start rowing with their neighbours about which one actually did hit. It might be you want to compare water with another liquid. So while we provide one very large flask here, we also provide a stand like this, in which you can place 2 narrower but also very tall cylinders, and then you can put water alongside cooking oil, really thick sugary solution or salt solution. It's probably not sensitive enough to pick up the difference between pure water and seawater, because our seawater is not that salty. It might be worth an investigation. Try it. You know, you don't have to see these differences. It's about making the children curious and giving them the opportunity to question. So deciding what goes in those 2 different measuring cylinders, and then timing how long it takes for the objects to fall to the ground. And obviously, when you're doing that, again, you want to make it a fair test. And so in doing that, those objects, if you're looking for differences between the 2 solutions, what you want is for everything else to remain the same. So you would choose something like a set of 2p pieces, because the time that it takes for every single 2p piece to fall should be exactly the same. And again, you've got to think about how you do it. Do you release it at the surface, or do you release it from the top of the cylinder? Again, you're making it the same every time, so that the only difference is the difference between the 2 liquids that you're investigating. Okay, so that's the friction box. The friction box comes with these 3 Perspex cylinders, which allow you to investigate buoyancy and upthrust. Any questions?
No, just got a comment about saying, you know, even without the kit, there's some great ideas to get children thinking about physics, the effects of friction, gravity, mass, etc. All good stuff.
Brilliant, thank you. Right, I'm thinking we've got about 3 kits to go, Claire.
Right, and we said it would finish about 1:15, so we've only probably got about 10 minutes if there's sort of any questions at the end. I think the microorganisms one is obviously the appropriate one, so it might be worth rattling through that, and then possibly the sound one.
Yeah, I'm moving to sound now. I'm going to finish microorganisms because it's my favourite one, being a microbiologist. Okay, we are going to play a little game now, folks, actually. There's a bit of interactivity in this, so it's not just a sit and listen. If you've got a notepad in front of you or just a scrap of paper, I would like you to write down these following words, please. Plastic pegs, ball bearings, gravel, sand, Rice Krispies, paper clips. Okay, we'll leave it at that. Okay, so there's 6 different objects. 6 things should be on your list. And I have these 6 objects all enclosed inside a film canister. If you can remember back, I hope there are a few in the audience who can remember film canisters and taking pictures on real pieces of film and then having to take film into a chemist to have it developed. Look, this is all pre-digital. Look at this, iCams, all of oldies on it. Yeah. Okay. So we've put these different objects inside a film canister, and you might be thinking, well, why? Why have you done that, Phil? Well, that's because, and if everyone goes quiet now, that's because they make a sound, and this is a great way to introduce sound to the kids. And we're going to play a little game here, folks. You wrote down those things. Basically, I'm going to shake something in a film canister. Write in the chat what you think it is you're hearing. It says you can't do practical science via the internet.
Ball bearing.
Absolutely spot on. Love it. Well done.
We're going for 6 out of 6 here, Phil.
Okay. All right, everyone's having a go now. This is brilliant. Right, I'm going to shake another one. Hopefully, I'm not sure where the microphone is on this thing, so I'm just.
Oh, nobody's launching in just yet. Paper clips is the general consensus.
There's gravel.
Oh,
gravel going through there. SD, well done, SD.
you've got different gravel in Norwich to us.
Okay, we're going to keep going. I'm going to be good as well. I'm not going to duplicate anything to try and confuse you, so it should be getting easier. We've got a 1 in 4 chance now. Again, bringing in a bit of maths to this session. People are giving this some
Pegs.
thought.
Oh, paper clips and pegs. Plastic. Plastic peg.
It's the pegs. Pegs have it. Okay, down to 3.
Paper clips. Sand. Oh, lots of disagreement on that one.
Okay, I'm going to do the 2 appear to be Rice Krispies or paper clips.
So the one in your right hand, I think, is Rice Krispies.
It is. That's Rice Krispies, and that's what I was doing before. And then I just picked up the paper clips for a comparison. So it probably won't come as any surprise. You should all get this one right.
That's the sand.
If anyone gets this wrong, I'm really worried because it's the last one.
Oh, it is 5 o'clock, Phil. Sand.
Yeah, that's true. Okay, so there you go. Really simple experiment. So you've got demonstration material there provided for you, canisters, but I think the kit includes empty canisters so the children can think about getting ones for themselves, designing their own one, and actually working with a partner in exactly the same way like we've done over Zoom here. blindfolded, or they could do it opposite their friend, challenging their senses. So many different ways. I'm sure as teachers, you're the really creative ones. You can come up with loads of different things that we could do, or that you could do with what seems like a simple activity. Also in the kit are tin can telephones, which are just wonderful. They don't work particularly well when I'm on my own in a laboratory, so I've not got those to demonstrate. But they're the two tin cans held on the end. You've got to make sure the string between them is tight. That's the really key thing to making a tin can telephone work. And you've got a hose pipe telephone as well in there, which works really well over really quite long distances. Okay, soup cans being recommended. We went with treacle containers actually. Soup cans can have slightly sharp edges. Yeah, so you've got slinkies, hosepipe telephones. Yeah, brilliant. The question is, do you have lots of them? Some people will have them already in their classrooms, other people won't. Have you just got one example in the store cupboard? Are they still working? What else do we have? We have so we have an oscilloscope in the kit, which is quite a technical piece of kit. It's a bit of an old oscilloscope, but it still does the job. But I've also found that you can do this sort of stuff online or with apps on your phone. So I'm just going to share a few of these with you now. This requires me doing a screen share. Okay, so this is at an address called academo.org, and it's a virtual oscilloscope. And what you're not seeing, probably, unless I'm just in the corner in very small, is I'm just plugging in a USB microphone. Okay, so you can see what happens when you speak into a microphone, and it forms different shapes. And these are the different sound waves at different frequencies. So if I start humming, okay, so that's really quite good, and you can get some nice effects. We're bringing in the shakers again here. That was sound. Very different pattern from the paper clip. This is just literally plugging a microphone into this something called a virtual oscilloscope. And I'm going to show you two more things with this. One that I think is great. It links to a second website. It's called an online tone generator. Okay, so are you seeing the online tone generator?
Yeah.
Yeah, okay. So it's set for 432 hertz. I'm going to play it through my computer. It's humming away at me. Flip over to the oscilloscope, stop talking. So you see by changing the parameters on the right, they will change back to the online. We'll adjust it to 800. We'll play. And you'll see it gives you a very different pattern. But generator, stop it. 300 as well. There's the 300 running through. So you can play around with this to get the different patterns. Okay, yeah, so all I was using was a microphone, initially speaking into it and seeing the waveform. After that, we then moved on and put a couple of websites.
So just a few more minutes left, so let's go for your favourite kit.
Let's go for the favourite kit. See how this works virtually.
I think some of the teachers might be familiar with this because I think a few food hygiene people have been into school sort of doing similar stuff, but it is a great demo, and we've got 3 or 4 of these kits, these black light boxes, so there's a lot can be loaned out at the same time, whereas some of the kits we only have 1 copy of.
And in terms of that, I would recommend, from our experience, try and be a bit flexible with your timetabling. You don't all have to do forces in October. You don't all have to do habitats in summer 1. There is still life in the school pond at other times of the year. Actually, September to Christmas generally isn't very cold, so there is still, well, not down here anyway. I know it'd be a bit colder in the north, but there's still lots of life around between September and Christmas, and that will increase your chances of getting hold of certain kits, I'm sure. Okay, so I'm just showing you the inside of a fairly anonymous black box, which is a source of UV light, safe UV light, I should add. So there's been so much talk in the media about hand washing. And little kids may have struggled, particularly, well, even year 6s may have struggled to think, well, I've washed my hands once, why do I need to wash them again? The chances are they've not washed them very well. And the best way to demonstrate it is using something called Glitterbug. You only need a tiny amount of Glitterbug as well. So it's just got a little plunger on it. That's more than enough.
Yeah.
It's just like a hand cream. If anyone is concerned about a skin reaction to the gel, then they can do it wearing gloves. So it's really good. They still can take part in the activity. If you look at my hands now, there is no evidence of any cream on there. And this is exactly like microorganisms, whether it's a virus, a bacteria, or a fungus. You have them on your hands all the time. We just can't see them. So we started the session looking at microscopy and really small items and imagery, and we're finishing by looking a different way at visualizing microbes. So you're pretending that your hand cream is a microbe. And that word pretend is really important, because what you don't want is your children going home saying, Mummy, I've got loads of microbes all on my hand. I've got to get my hands clean. And then the pumice stones coming out and they come into school with red raw hands the next day. We don't want that. But there is, a really important message here. How well do you actually wash your hands? And by just rubbing the hand cream on, placing it in the UV box, which is here. I'm not sure how well the UV is going to work, but there we go. So you just place your hands in the box. It's long wave UV that's nice and safe, so it doesn't matter if they have their hands in there for a little while. Can't tell very much.
Yeah, we can see that now, Phil, yeah.
Are you seeing my hands glowing? And obviously if I pull it out, then once again you can't see anything. But if I bring it closer to the screen, you'll see my hand is covered in it. So you can imagine one child puts the cream on, they shake hands with the other person, and they shake hands around the class, and you could see how very easily you're going to get transmission of the disease around the class. You can touch objects with the cream, and then you can put the object under there, and you can see evidence of where it's been. And this is how, and then you can send your children off to the toilet. They go, I'm not going to the toilet, everybody, but I am going to a sink.
So there's lots of trips and backwards and forwards to sinks and washing hands and stuff like that, but it is an important message and obviously very topical.
Yeah, so, and you'll know how long I've been off screen, so I haven't washed my hands very well. We come back, and sure enough, I've washed my hands, but look, it's persisted in the dry parts of the skin on my hands. It's persisted around my ring. So that's providing an area where the microorganisms are trapped. If they've got long nails, it'll get under the nails. If they've got plasters, it'll gather around there. But you can also get them to bring back the cloth with them. And sometimes you can see it, different colours here work in different ways, different colours and different types of material react under this. I don't know if you can, yeah, blue doesn't react very well, but baby wipes are really good for this, particularly if you don't want the children running off to the toilet, if the toilet's quite a way away. So you can provide a pack of baby wipes with it. And the really bright ones will think, okay, well, I've wiped my hands with the baby wipes, but actually all I'm doing is moving it off that hand and pushing it onto that one. So I'm kind of recycling the disease on the same tissue. And you can put that object in the UV box to provide evidence of that's what they're doing. And then, as I say, you can put objects under there that have been primed. You can prime the door handle to the class with a bit of the glitter bug before they come in. So, yeah, I think it's a beautiful kit. You might have done it already with paint or like a glitter-like substance. But all the time, it's visible when they do that, which is great. It's, you know, in the absence of kit, it's the best way of doing it. But this history to it. These are exactly like microorganisms. You can't see any evidence for them on your hands at all, but they're still present. And that's why we have the problem we have with COVID-19 currently, that people have been touching surfaces. People have been traveling on public transport. Britain is a major transport hub. You can imagine the number of people traveling through London, traveling through the underground, when we thought, oh, it's only a bit of a flu-like virus 12 months ago. And then the number of people that have touched those same surfaces. It provides a context for really explaining a lot of what we've been seeing over the last 12 months. Hand washing has always been important. It's really prominent in people's minds now because of COVID, but it's something that's taught in PSHE for the younger ones. It's something that you can link to the microorganisms units in year 6. So there's lots of different applications for this.
Yeah.
So that's the microorganisms kit.
Fabulous. We've just got one question about the wavelength. So someone's asked about the wavelength, the UV light. What the wave?
Yeah, the UV. It's what they call long UV rather than short UV. Short UV is the damaging one. Long wave UV isn't, which is why it's safe to have your hands inside the box. Yeah.
Yeah. That's great, Phil. I think we've just about run out of time. We've still got a few people still with us, but you know, I think that's fantastic. It's just been a real whistle-stop tour over some of the kits from someone that actually started this scheme 20 years ago. So you know, that's fantastic. And I just wanted to say thank you so much. It's you know, we wanted to give it a go. And you know, the connection problems have been difficult, but we've got the general gist of what you've been trying to say. Lots of thank yous as well from people. And I think really just to say that the kit is there, it is available, it will be fully funded after Easter, and hopefully with COVID we'll get some more flexibility on what we can loan and what we can't, but it's great, and I would just love to see it used. So please, STEM ambassadors, you know, come and have a look at the kit, fill in the forms, and you know, get that kit into schools and being used, because it's been sat on a shelf for 8 years. So I'm delighted that we've managed to find it, and I'm delighted that Phil's been able to do a little bit of an overview in terms of how you get it. So just contact the hub. So there will be an email address which we will set up. At the minute, it's stem@rtcnorth.co.uk. Don't worry about writing stuff down. This will be followed up in an email, and there'll be various. Yeah, unfortunately, they're only available after Easter. There are a few bits and pieces that have been missing in some of the kits, like batteries that have needed to be replaced because they haven't been used for 8 years. So it's taken us a little bit of time to get all the missing bits and pieces pulled together. But certainly, we're hoping to get that scheme up and running after Easter. So all the information, all the details with everyone who's registered for this afternoon's course, that will all be sent to you by email. And after Easter, yes, and all the electricals have been pat tested last week. So all the electrical pieces of equipment have been pat tested and passed. Get my teeth in. So they're all ready and safe to use as well. And yes, just to say a big thank you, Phil. You know, we got there in the end. I know you're delighted that kit is up and running again. You said it was the best Christmas present when I rang you just before Christmas.
It really was, and so often in education, those of us who've been in it for a few years now, you hear of things that they come and they go, and I think it's so great that this is still alive. Because there was a major investment to get it to those 3 centres in the first place, and yeah, just go ahead and use it, everybody. I'd love to hear how you get on. Hopefully I'll get the opportunity to come up and maybe work with some of you directly in the classroom, or in a more face-to-face scenario. But all things considered, I've loved doing it out here like this, because of having Claire and your interaction through the chat. It hasn't felt as weird as I thought it might, me talking to myself for an hour and a half. But yeah, I think it's worked really well, and given you a really good flavour for what you can do with the kits, some of the pitfalls, some of the things we've learned over the years. And yeah, go ahead, have great fun with it, and good luck, everybody.
And we'd love to have you up in the Northeast, Phil, face to face, because you can't beat it. I think the new world will be a hybrid model, but to get you up to the Northeast and maybe do a session here at RTC in Sunderland, get some teachers, because it was so popular when we ran it through the Science Learning Centre. Get you up, get some teachers, and just have a good play with some of those pieces of kit that you've shown us, particularly the woodpecker. I need to dig that out.
Exactly. Take it home for the weekend, Claire.
Yeah, absolutely. Thanks to all the teachers and all the STEM ambassadors who've joined us tonight. We've overrun slightly, but you know, it's much appreciated. And once again, thanks, Phil. And all the information will be sent by email, so you know exactly what's happening after Easter. All right, you can breathe now, Phil. Bye-bye.
Cheerio. Bye-bye.